it's because I arrived like 15 minutes ago, and I've been flying from Sweden to Berlin and here, and I landed 15 minutes before the talk, so running. Anyway, my name is Jacob, as you heard, and this is my Twitter handle if you want to tweet something nice or something bad about the talk or give me some feedback. I'm going to start to just introduce myself a little. And I started in the software business doing consulting. Yeah, it's boring, you know, all these people in suits and everything. You've probably been there, a lot of you. And after doing that for a while, I ended up at a company called BERT, which is a Swedish startup doing advertisement analytics, collecting lots of data and just crunching it and producing nice reports for the advertisement industry. And we were receiving 2 billion writes per day last month, which is data that actually has to be processed and put into a database and so on. So it's kind of a big data system. But fact is that I actually left BERT this Friday. So if you look at my Twitter bio, it will just lie to you. So don't trust it. I'll update it as soon as I have something, as soon as I have some time. But currently, I'm kind of back to square one, like trying to survive. I'm starting a company with a couple of friends, and yeah, you're gonna see what we're up to at the next conference or two. But anyway, I'm here to talk about dependency management in the browser. And I should probably say this, as I always do. The talk is full of my opinions, and it's not to be taken too literally or like a truth and something you should go out and do, but rather to make you think a little and make you curious about some technologies. And I also want to say that what I'm going to talk about is not for making home pages for your kitten or something like that. It's for building web apps, complex web apps where you have a lot of stuff, not Mitten's homepage or whatever. But first some quizzing, because I love being quiet for a while and let you guys talk. So, who of you are using the Microsoft stack, like Visual Studio and C# or those things? Almost no one. Then I actually have the heart to show the next slide. I'll get back to that later. But anyway, second question. I sincerely hope that most of you guys have actually thought something like this several times about several technologies. I know that I have, so this can obviously refer to a lot of things. But I found this when I was researching my talk, and yeah, I'm gonna explain exactly what it's about. But to do that, I'm going to tell you a little story, like rewinding my own development of learning things in software. So I think the first time I encountered some kind of dependency management was when I started doing Unix, somewhere around 99. And this apt-get was like the most amazing thing ever. I could install something with one line of code. Like, wow, it's not like download a file and go through this wizard, choosing where to install it and whether or not you want an icon in your start menu, and yeah, all those things. I found it just amazing. And then apparently Mac could do the same thing. There are several systems for the Mac, as you probably know, for installing software like this. But yeah, the point is that the Mac could do it with the programs. And then when I started doing Ruby, the Ruby gems was like the most fascinating thing. You could download pieces of software for your software, not just programs, but actual libraries using the command line and just scripting it. How many of you have actually used Ruby gems? Most of you, cool. I hoped so. And then came the iPhone, which kind of does this as well with the apps. So that was the first time, I think, that regular users got to see this. The thing I was amazed about 8 years before that, and that had probably been there for a decade or 2 decades, or I don't know, 3 decades before that, when I wasn't born. Anyway, the story continues. I started doing some Node a couple of years ago, and Node could do it as well. And suddenly, all these software platforms had this way to get your libraries into your environment. And to go back to this, the guy who actually said this was working at Microsoft, and he was talking about Nugget, which is a similar tool for the Microsoft stack, which is a free and open source package manager for the .NET framework. And that's amazing, right? That Microsoft finally manages to do this as well. And it's good. I think that's actually going to make the Microsoft stack better, even though they have a long way to go. But the point is the third question. That what is the JavaScript approach to this? And I'm not talking about the server, because we have Node and these things. I'm talking about the client. How do you do this in the client? I mean, you probably sit there and think now that, oh, I have this way and I have that way, and everyone is thinking about some different kind of way. But what I had been doing for all these years, doing web development, was a simple 4-step procedure. Find the library that you want to use, download it, the source, put it into a folder somewhere, organized, and then let the pollution begin. Just drag it in and put everything there in the global scope. Amazing. Gotta love that, right? And the pollution, that's just the beginning. There's so many headaches. I mean, jQuery, right? And then we have prototype, and we have underscore, and we have backbone, and we have all these 18 templating engines. And yeah, it just piles up. Looks like the office of a professor or something. All these folders and everything, and it's just jammed in there. Put it on a stack and no order at all. And it becomes kind of a maintenance nightmare. How are these things interacting? This thing is overriding that, and that requires that version, and it just blows up, and you can never upgrade anything. And you don't know what is causing things to break, and yeah, it's just a pain. And then it brings all these stupid habits. Like, oh, we gotta add semicolons to the beginning of our files, because otherwise we can't concatenate them because some idiot finished his file with something else. Like, why? And then we start to do this premature minimification. There's not really any point to downloading libraries that are minimified, because you're gonna scrunch them together and minimify them anyway. And when you get the minimified libraries, you can't read the source, you can't figure out what's going on, you can't debug it. But still people do it. And also, we have no choice but to check in our dependencies into our version control system. And that's something that you could debate whether or not you actually want to do or not. But the point is that this is forcing us to do it. We don't get a choice. And we also start to copy-paste everything. Like, oh, I have this library, and I edit it like this, and now I have this version that's unofficial, and you can have it. And then we start copy-pasting like small pieces of code as well. We're already doing it with the files. Why not do it with everything? And it's just causing us to work in the wrong way. So, I mean, you can obviously see my frustration. And I think all of this, it's just... and fact is, front-end developers, and I don't really consider myself a front-end developer, but the last couple of years I've been doing a lot of front-end coding, so probably I am one of them now, one of you, I guess. And that's a compliment. Because front-end devs used to be like script kiddies, or at least that was the status you had. Like, you're mashing together these cute little JavaScripts, making things bounce on your page. But that's not the case anymore. They were script kiddies. These days, we're building actual apps in the browser. I mean, haters are gonna hate, but front-end devs are not script kiddies. They were script kiddies. These days, it's as sophisticated as anything else. And JavaScript is popular. I guess you've seen this on GitHub, but it's by far the most popular language. So it would be stupid to just dismiss this and say that, it's not real development. They don't need real tools. They can play around in their sandbox. We do need real tools, and we do have real tools. The medieval ages are over. We're not coding like that anymore. We have all these things to solve these issues that I pointed out. And yeah, that's what I'm going to try to dive into. And I can't talk about all of them and all there is to know about it, so I'm going to touch on a couple of different approaches that I chose because they are different from each other. There are lots of copycats that are doing very similar things to these, but these are fairly different. So I'm going to describe the ideas and tease your mind a little, hopefully. And I hope that there's not too many of you in here that have already used all of these, because then this talk will be useless. Then you can go out and code that cat homepage instead. So, yeah. Let's see. First off, I think we should start with just setting the bar. I think most of you guys already know this, but some of you probably don't. So let's dive into what CommonJS is. It's a project, as it says here, with the goal of specifying an ecosystem for JavaScript outside the browser. And now you're thinking, why is he talking about that? Because this talk is about the browser, right? But this is kind of the first serious attempt to standardize how to do things that we never really had to do in the browser, like how to include files and so on between files and in projects. And CommonJS is not just about package management or dependency management. It's about a lot of things, but the module system is one of the parts, and that's what I'm getting at here. So if you've done any coding in Node, you've probably done something like this, where you can use a function called require and just require in a file that's somewhere on your file system, and then use the object returned from that and use some function on that object. And you can do the same with another file here. And if we look at what could be inside of those files, let's dive into foo, which has a square function. Then foo can simply just contain this. It's an object called exports, onto which we add a function called square. And that way, when we write require in the other file, we will get this exports object returned. And we can also do things that are causing side effects, like printing that we have loaded foo. And we can do kind of the same in bar, just putting in a version number, adding a cube function, and then printing loaded bar. And the thing is that what's different from this approach compared to in many other languages is that these require statements are not kind of creating some dependency between the files and including things magically in the global scope. They are actually running the code inside of that file as if it were kind of a function and returning the exports object. So when we run this line will print included foo, and then we'll print the square of 4, and then we'll print included bar. And that's not what usually happens in other languages, where you include everything at the beginning. Here you can actually do it whenever you want to. And like I said, hopefully you already know this, but I just want to make sure that everyone's on the same page. And in particular, you can do fancy things with this, like including random files. Like we toss a coin, and then we include foo or bar, depending on how it turned out. And if we got bar, obviously version will print the version number we had in bar, and if it turns out as foo, we'll just get undefined because there's no version variable in there. But you can probably use this for something crazy. I don't know. And then the second thing that you also have to be aware of is npm, which is the node package manager. And how many here have actually used it? Yeah, that's good. About half. Then it's probably not useless to tell you this, but I'm also happy that you're aware of it. So it's exactly like Ruby gems and all those other things. We can use it to install packages right from the command line. And then we can include them in our source like this. Instead of referring to an actual file on your system, you just refer to name. That's equal to the name up there that you've included. And as I said before, this is for doing things outside of the browser. This is JavaScript on the server, and that's the intent of CommonJS, and blah, blah, blah. And it's very easy to just get up your own package into the system. I've stolen Backbone's package.json, which is the file that defines how this should work. You add a name that has to be unique for your package. You write the description and all these other things. And in particular, you write down which other packages does this package depend on, and what version does it require. And also, which file should it start from? When you include it, what should be the actual return value from your require statement? So if you just add a file like this into your project and write npm publish, the stuff will end up on npm, and you can let others use it. So that's for the basic talk. Let's dive into the first browser system then. And this is called Browserify, and is something that I've used quite a lot. And the purpose of it is to make node style require work in the browser. So you will actually be able to include things like Backbone, as we just saw, into the browser using something very similar to what you would do on the server. Let's look at some more code. We can write something like this in our main.js or whatever that we have in the browser, in the client. We can require files that are relative to this file, not on the file system anymore, but on the path, on your URL. And we can also include modules that have been installed by npm. So this looks exactly like what you would do on the server, but this actually works in the browser. And it does that by this tool, Browserify, that you just say, I want my main.js file to be handled as a browserified version of what would happen on the server. And then we just say that the output of whatever this produces should end up in bundle.js. And then we include bundle.js in our page instead of main. And obviously, bundle.js will end up with a lot of stuff that wasn't in this file. It will do some magic to get this to work. But the point is that it will do exactly what you expect it to do. And in order to use it, you just write something like var main, require main, which will run that file, because it won't be run until you actually require it. So you need some other script on your page to actually start it up. Or better yet, you can actually put this inside of a local scope and use it exactly where you need to use it, and not just bloat everything into the global namespace. So this way you can wrap up different pieces of code and use them in just the places that it's supposed to be used. And to get some understanding of what's going on, before that, it also resolves nested dependencies. So in the case of Backbone, as we saw before, if you let main here require Backbone, then when you run Browserify, that will also install underscore, as Backbone depends on underscore. But you don't have to think about that. And you won't get the underscore into your global scope, because you have not asked for underscore. Backbone did. So you will not start to bloat everything just because one of your dependencies depends on something else, which is really, really neat. And what actually happens to this output file that you produce is that there's some magic put at the top of it, defining a function require, which is what you use in your other scripts to actually access this. That's the only thing that gets put into global scope. And then a piece that looks like this, that says require.define, and then the name of the file you entered, and then a function that takes a couple of parameters, require module, exports, directory name, file name, and process, will wrap the code that you had in main.js. The code from main.js will be inside of this function, which is what causes it not to run as you put it on the page, but only if you write require main. Then this function will execute. And these things are used in Node for different things. Export, you already saw. It's for adding on the things that you want to export out of your module. And this mocks them, so to speak. You actually get access to those inside your main.js, even though there aren't actually any function called require, for example. And now we're not using exports here, but we could be using it because they are suddenly available and doing exactly the same thing as they would on the server. So this is kind of the server and client united. You can use underscore both on your server and on your client this way, and you can include it in a more sensible way than just copy and paste the code into your source. And there are obviously some things that you can't do. You can't do file I/O as you could in Node because you don't have access to the user's file system. So you can just do things that are possible to do in the browser, obviously. But that's actually, I would say that most of the libraries that are on NPM can be used in both environments because they are not directly accessing the operating system and those functions related to that. So that's the first one. That's Browserify, which I find cool. And then we have another one that I think it came out earlier, and it's called Ender. And they brand it as the no library, which sounds weird, but it's definitely not a library. They should remove the word library completely because this is a system for handling dependencies and putting them into your application. As it says here, it's a package manager for your browser. I don't know why they say library. It doesn't do anything on its own. Probably this looks familiar now. We say Ender and then build and then a couple of libraries that we want to put in. And then we include some script called Ender into our page. Looks exactly the same as Browserify, right? But the way we use it is different because they thought that the Browserify way was too complex, or rather, since Browserify didn't exist, they imagined an easier model to begin with. So these things that we installed, they have this library called DOM-ready query, which is like a lightweight jQuery module, and then underscore. They will all add all their functions onto the $, variable. So we don't have jQuery here, but we still have a $, variable because Ender introduced it. And everything gets yammed onto that variable. So map is from underscore, Ajax is from the query library, and yeah, this that looks like jQuery is also from the query library. So no requires needed. It's a little simpler. It's actually very, very simple. Everything ends up on the $. And it uses NPM, just like Browserify. So it's not a package manager. It's just a way to bundle packages into your application in some structured way. But everything is still kind of global. Just because you put everything on the $, doesn't make it like localized. And it obviously doesn't play well with jQuery since it starts to mess up your $. And actually, I'm not a huge fan of jQuery. I think it's too huge for many of your tasks, but there are so many libraries out there that depend on jQuery that it's hard to build something without it, at least in my opinion. So something that can't play well with jQuery means it's hard to use. And then we have Jam, which is, yeah, once again, I just quoted the developer of it to get an objective idea of what it is. And then I'm going to give my subjective view. So it's for front-end developers who crave maintainable assets, and it's a package manager for JavaScript. And unlike other repositories, there should be a parenthesis here saying NPM. We put the browser first. So this is not for bundling things together in the browser, in your app. This is an actual repository with actual dependencies, like NPM. So in one way, it's more comparable to NPM than it is to Browserify or Ender. And the big difference is that it's built to put the browser first and not the server. Just quoting the pitch kind of from their page. It manages dependencies. Yeah, right, that's exactly what I said. It's fast and modular. I suppose that's true if the dependencies in it or the libraries in it are actually fast and modular. And you can use it with your existing stack. It doesn't have anything to do with how you write your code. It's just about storing modules. And yeah, custom builds and focus on size and blah, blah. Focus on the browser. That's the important point. Jam actually cares about CSS and HTML, which are often part of reusable components that we want to have in the browser. Sometimes there are pure JavaScript things, like underscore and these things that you can use on the server and on the client. But when you want things to have a visual appearance or something, then NPM is not really made for it. NPM can do it if you, I mean, you can put all your HTML and CSS into your JavaScript. You can just create CSS tags and create DOM nodes from JavaScript, obviously, but it's not as straightforward as Jam is making it. And this should be really familiar by now. It's just yet another program that you use on your command line, and you say, I want these and these dependencies, and it creates a file that you can use in the browser. Once again, same story, but different usage. And once again, we use require to say that we want this, this dependency, jQuery in this case, and use it. But something is different. We're not calling require and returning what we got out and use that. Instead, we're requiring an array of something and putting in a callback and then running things. I suppose some of you have seen this as well. Some hands up, so let me know. Not too many. Oh, cool. Then I actually have something to talk about. What's going on here is, no, let's wait. I'm going to finish Jam first, and then we'll jump back to this, because this is starting to get more complex than the previous two. Once again, if you want to publish a Jam package, you do something very similar to NPM. You can actually publish things to NPM as well, because you just have to add a Jam property into your package.json instead of the dependencies that you had in NPM. And inside of Jam, you put your Jam dependencies. And suddenly it has to be everywhere, and everyone will be confused. But you don't have to do both of these. You just have to put it into the system that you want to use to manage your packages. And on the command line, then you just say Jam publish, and it will publish this into Jam. So let's jump into require.js, which will actually explain that weird use of require that we just saw. So this is the opposite of Jam. This is not a package manager at all. This is just a way to include your files and manage your files in your browser. And it looks like this. And that's what Jam is using by default. You can change it, but if you use Jam the vanilla way, it will be like this. So this is something called an asynchronous module definition, or AMD. And the idea is the same as with require as we used it before. But instead of returning it, we're getting the result back in the callback. And as you're coding JavaScript, this pattern is obviously not new to you. Every time you're doing something asynchronous, like Ajax or setting timeouts or whatever, you do this. So hopefully you will already start to understand the benefits of it. Like, maybe it won't block. Maybe I can do things in parallel, and so on. So the idea is that, I'm going to explain it by showing you how this util file that we're including looks. And there's an extra function here in require.js that's called define. So we have both require and define compared to the other ones where we only had one function or variable. So we define a module in this util.js file by giving it some names of dependencies that we want this file to depend on. It could be jQuery or it could be underscore or whatever. And then we put in this function just like the require looked like. And then we can do all kinds of things in here. We just write our code as usual, but we return an object that is the object we want the user of this module to get access to. So in this case, we have a function foo and a variable bar that will be accessible from the util object here used in this code. So we can encapsulate functionality and require it in like this. And the reason this looks a little more complicated, right, than the other ones. We have to say things twice to begin with. We have to state the names of the dependencies, and then we actually have to create variables for them, duplicating everything. So if we would have 10 dependencies or something, this would start to be a mess. So we can actually use this exactly the way we would have used it in CommonJS, or as Browserify use it, and so on. That we just say that we require these dependencies, because this time we haven't given the define method any dependencies. So instead, we get the require method in. That's the only thing we get. And we can use that to require the dependencies we want. So if you kind of cover the first line and the last line, it looks exactly like what NPM would expect and what Browserify would expect and all of those. You can do exactly the same thing. You just wrap it into this define block. And obviously then, like, what's the point? I'm getting to that. That's all about the asynchronous part. But there are some gotchas. You obviously can't do this properly if you randomize your dependencies like I did before. Because you can't, this code, or rather, you can't turn this code into something that does that if you run the code first. What happens to this is that the require.js library will look at this code and find all the require statements and figure out that you want to use these libraries and turn it into something that looks exactly like this. So that's sugar. It turns that into this. And if you write something with random dependencies, it can't figure out what to do. So it's not a complete copy of Browserify and what you can do with NPM and those. You still have to follow some conventions, but it's almost one. So the point is that if you're doing this in an asynchronous way, let's back up again. This code in here will not run immediately, and you can have more code down here that will start to run just in Ajax, as in using Ajax. And that could seem a little weird because you need the util library to start running your application, but then you're going to do something else, and that will start running instead. But if you start thinking about it, that's just the way you code JavaScript anyway. And what's good about this is that when the require statement is encountered here, the browser can load this file. It doesn't really have to load it beforehand. You don't have to load in all your JavaScript files before your application can start. You just have to load the start file, if it's this or whatever. And then when it encounters a require statement, it says, I need this dependency, damn it, let's load it. And when it's loaded, this code will run. And if that dependency has other dependencies, those will load as well, and so on. For example, if you're using, I think my typical use case for this is when doing some graphing. That's usually very heavy. I use high charts quite a lot and other tools like that. But I don't have graphs on every page in my application. So I don't want to load them on pages where I don't need them. And if I'm doing kind of a single page application where I don't reload the page, I need some other way to actually load it in when I really need it. And I can invent something myself, but this is one of the solutions that you could actually use for that. So it helps you to actually just load what you need when you need it in the right context, and just if the user actually executes that code. Maybe the user doesn't click on your button that opens up the modal with the graph in. Then you don't need to load the graph library on that page, and so on. And require.js is not coupled with any packaging system. You can use it with Jam. You can use it with NPM. You can probably use it with anything else that's out there. And if you're already used to CommonJS because you're writing Node, or if you've used Browserify or anything like it, you can almost think of it the same way. It's almost a superset. It's slightly more complex because it's one level of functions above everything. It's asynchronous, and there are some gotchas. But in general, it's a superset of CommonJS. So I see that I have 6 more minutes, and that's kind of perfect because I want to start drawing some conclusions from this. And looking at this variety of tools that you can use makes me think about templating engines, which is like a weed. They're everywhere. There are so many. Who haven't read all these posts on like which templating engine should I use? Here are the 117 different ones, and we're comparing them all, and they're all the same. So I think JavaScript is great because there are so many solutions. It's so easy to attack a problem, and it's so easy to spread it, and it's the most used language, so everyone needs solutions. But it's also hard because there are so many solutions to everything. So you always keep asking yourself, which one to choose? What should I do? Well, what's the right solution? And the frank answer is, it depends, as always. What is your use case? What is it that you want to do? And which of these tools actually works best in that use case? And that's just something you have to figure out. And that's the good part, because you can help. You can help everyone figure out what's the best tool. Because we should just get on and use these things. We should not stay in those dark Middle Ages where we copy and paste our code around and don't have any idea of how anything relates to another and can't upgrade anything. We should just use these things. Learn them. Learn one of them, or learn 2. Play around with them. Use them for a small project or something, and speed up the natural selection, so to speak. Because there are some of them that will survive and some of them that won't. So help the community kind of gravitate towards a common solution by just start experimenting and show that it's not script kiddie style anymore. This is as real as any other software development. But please, whatever you do, just stop this. Manage those dependencies. Thanks. Right, over there. Yeah. Yeah, right. Yeah, the question was if it's the case that all of these tools require a compilation step before you can use the code. Yes, all these tools that I showcased does that. And I was actually thinking about throwing something in here that I have been working on to solve that issue. But I simply didn't have time, and my tool, as always, it's not nice enough to show it off yet. But there are attempts to solve that and do it more like on the run or on the fly.
Some kind of development mode.
Exactly.
When I develop, I want it to require. When I run it, like real, I want it to be like browser.
Yeah, a development mode, he said. And that's exactly what some people are working on, so that when you're in development, you don't have to go back to the command line and install things. You can just start requiring them like magic. And when you want to deploy, it builds everything for real and sends it out. So you don't have to do things on the fly. But yeah, there are no major solutions to it, but I think they're popping up really, really soon. Any other questions? Yeah. Yeah. Right. So let me repeat the statement then, since I don't have a reply. She said that in Ruby gems you install things to the whole system, while in npm you install them to the local repository. And to say something, you can do that in npm as well. There's a flag to say that you want to install it for everywhere. And I actually think there's something for Ruby as well to do the opposite. Yeah, it just takes the tool. Yeah. Right. Thanks for the statement. Any questions? Yeah. 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 The question is if there's something coming up in the next standard, ECMAScript Harmony, and yes, there is. I think, if I remember correctly, it's quite similar to require JS. It's an asynchronous way of loading your modules. So it's actually on the more complex end of the scale. And I think that will actually be harder than what it is in many other systems. For example, Ruby, because Ruby is not asynchronous by nature as JavaScript. So we'll see what actually works and what people likes. But come on, we're used to doing things asynchronously. So I think something like that will be the case. Nothing else? Yeah, one more. Yeah, that one, I think. No, it actually won't, because this will be pre-processed into this. When the code is compiled, it will become this code. So it will look at the source, find the require calls, and see that you're using this. And then it will require that the usual way, so those modules are loaded beforehand.
So if I try to use require without this r.js step,
yeah,
then it will just not work.
Yeah, yeah, we have to pre-process it in order to work. Yeah. 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 Okay, so the point was that you can use this style even if, without, sorry, you said? Yeah, without the optimizer. But that's still a pre-processing, right? You don't optimize it, but you still, since it looks at this function. Yeah. All right, now I see the point. Yeah, the point is that you don't have to run the compiler yourself. It will do it on the client when your code runs. But before the statements execute, it will do that pre-processing. That's right. Some finishing question? Then I'm actually going to start enjoying the conference as well. Thanks, guys.